Well, if you remember from last time, we were playing around with the OLED display, just getting some of the basics down with it. And what we want to do is dig in deeper into the code of what actually drives that display, what's going on behind the scenes, so we can learn how to manipulate it. I don't know if you remember, but we had the ASF set up so that for the display driver, and it includes SPI routines, delay routines, system clocks, dial port, general purpose routines, all kind of included under there. And so I dig down a little deeper into the code, and I'm going to concentrate on this one line that is the write text function, and we'll start from here and try digging down deeper from here and see what's going on behind the scenes. To keep things simple, I'm just gonna um, type out the word board in capital letters, so we don't have to deal with lowercase or any other words, and see if we can analyze it at that level. So when I programmed it, it'll come up, and you can see here displayed here in the top left hand corner. So we'll right click on this, and we've got this function here. So we've got our basically our string, which you can see I don't even set up as the one I did before. I had a constant set up saying hello on board. In this case, I'm just inserting the string directly into the function parameter, and the string it says board in capital letters. So you see our function, we have a pointer pointing to the string, and then a couple of variables are initialized here, a pointer and a character pointer, and then I just for the for loops. And then the first part of the function here basically is this while loop that's checking to see if our string, if we run into a null character. If we don't have a null character, and remember that with strings, in this case, the null character is implicit. Usually at the end of the string here, and you can't see it, but it's implied that it's there. And so our function is looking for that right away. It says if the string is not a null character, then we will execute this area of code here. If it is null character, then it will skip over this section of code and go down to ssd1306 write and write data and write null characters out. So basically not displaying anything. It's not going to display anything on the display. But if it is not a null character, then say it's going to hit the first letter in the string, which is a capital B. So it's not a null character, so it's going to go down to the next line. Now it's going to check if the pointer, or I guess this is the dereference pointer, is if it's less than, the value that's pointing to is less than hex 7f, which is equivalent to 127 in a decimal. If the value there in the string is less than hex 7f, then it'll execute this section of code here. If it is more, oh yeah, I made a mistake there in the first one. If this first condition is not true, if it is a null character, it's not even going to go down to write. It's going to skip the whole thing and go down and just increment the pointer to the string by 1. But in this line, if the dereference pointer is pointing is less than the hex value 7f, or decimal 127, then it'll execute this area of code here. If it's greater than hex 7f, it's going to skip this and go down and write the null character here. All zeros, a byte with all zeros in it, and basically not write anything to the display. And then move on and increment the pointer up here, which is remember, is pointing to our board string. It'll increment it by 1. So basically, if it started at, I guess you start at the end of the string after D, and it was sitting on the null character when the program started, it'll check for it, say, oh, it's null. I'm skipping all of you, and I'm going down. I'm going to increment the pointer of the string to move to the next character, which would be from the end of the the board string. Right here, say it was stuck. It was on the sitting on the null. It would, it would just skip and move back to the front to the B. Okay, so say to this point we've met all the conditions. It's not a null character. The dereferenced hex value that the pointer is pointing to is less than 7F. Then it assigns the character pointer here and assigns it to point to the first element of the font table. Now what's the font table? Let's go down, dig down, look at it. Now the font table is an array with 95 members, and is basically our ASCII characters. Like UA stands for uppercase A, uppercase B, uppercase C, etc. And then you can see the ends up here, the numbers, number 9 would be that one. And then down here you've got your L's for lowercase a, lowercase b, lowercase c, etc. Now notice that the array starts at 32 and goes down and ends at 126. So we look at our ASCII table. You'll notice that at 32, that's where we got space starting, and then our characters that we need to display, our regular ASCII characters, parentheses, etc. And then down starts down to the numbers, and then less than, greater than signs, and then our capital letters and our lowercase, and running all the way down. In this case it goes to delete, but you'll see in the font table that they're not going to use delete. We don't need it. It'll end with the tilde sign here at 126, and it won't start at 0. It'll start at 32. Why? Because, well, look at what we got here. We got a bunch of crap we don't need. Carriage return, shift in and out. We don't need to display that to display. We need to display letters and characters and symbols. So they're skipping this whole section here and starting at 32 and moving on down. So you can see that here in this font table array. Let me see, where was I? Yeah, okay. So the character pointer is assigned to the first element of the font table array. And then in here, this is interesting, made me scratch my head for a while. Why the heck is 32 there? I'm not getting it. But then when you look at, like I say, when you look at the ASCII table, they're subtracting 32. They don't want to start here. They want to start over here. Hence the reason for the 32 being here. Then your next line's a for loop with our initialized character up, or variable up here is I, and then it's set to 1. And then if I is less than or equal to the character pointer element, then it'll actually write the data, which is on this line in increment I. And obviously, what I said before, where the string is not less than hex 7F or 127, then it'll skip down here and just write a null character. In other words, not write anything to the display. But because we're, say, for example, we're on the B here, we're on the capital B now, so it's not equal to null. It's less than hex 7F, so it's going to go to the font table and subtract 32 and start from like I said on the font table here, from 32, and then display B, uppercase B, which is right here, and we'll right click on that, go to its implementation, and you can see here uppercase B, hex 42, decimal 66, an array of 5 elements, and 4 of those are these bits to bytes. And here you can see the bits to bytes is the series of bytes, and then there each one is left shifted to fill the bytes into this unsigned int. Now I'm not sure the details here of this. I haven't quite figured out the details of if that's the actual bitmap that's writing the character out, each pixel out to display that character. I'm not quite sure of that yet, but I'll definitely be checking more into that, trying to figure out more details of that. There's a lot more to go on this function, because this is kind of still an upper level function, and this actual ssd1306 write data function here we'll dig down to more in the next video, and it has all the actual functionality of initializing the SPI, if that's what we're using for the interface, and then sending the actual data over the wire into the into the SSD driver chip to be displayed on the display, on the OLED display. And I'm not 100% sure on this, but I'm thinking that it's going to look at the hex value. This is going to be like you have an array and you say, okay, I want you to print out element 7 in the array. Well, this is a similar thing where it'll start at 32, and then it says, okay, print out the hex value for uppercase B, basically right in here, and saying, okay, go to that, which I guess is, I'm thinking it's a hex value, because they're using the hex value up here to check. You don't got a range past 126. So I'm thinking this is a hex value as well. A dereference is pointing to the dereference value in the array, which is a hex value for uppercase B, and then it's saying, okay, go ahead and write that data out, is what I think is going on here, though I'm not 100% sure, not even 80% sure, but it seems to make sense to me. And if anyone wants to correct me on that, that'd be good. But anyways, that's a general overview of this function. Run out of time here, and then next video we'll go to this write data function, and it's got a bunch here, basically 2 sections, if it's USART SPI defined, or if it's SPI interface defined, and then it sets up a bunch in here of, like I said, of setting up the actual SPI interface, sending the byte over the wire and into the display, and then actually running this displaying the character out. But that's like the next level down, and that'll be a whole nother video there. So just a quick review here. So we got our string board and a pointer to the string boards. It's pointing to the first letter in the string, capital B. Checks to see if it's null. No, it's not. It's capital B. Checks to see if it's greater than 7F hex. If it's not, then it'll go into the font table and print out with the right data here. Basically, write out that character, and then increment itself along to the next character until it hits the null terminal there at the end of the string, and then that function's done.